In this video tutorial, we're going to discuss how we can include the effects of hyperstatic or secondary actions from post-tensioning in column design using Adapt Builder and also our integrated column design module and program S-Concrete. There's a couple of things to look at here. The first is that when we create PDelta combinations in Adapt Builder, and this was introduced in the 2019 version, in our load combinations, PDelta, while we can assign a factor to hyperstatic, the program ignores the hyperstatic reactions included in this combination. So if I create a PDelta 1 that includes hyperstatic or a PDelta 2, I'll just call this PDE2, and I'll change that to the PDelta type. And let's say I have a repeating combination, but I just ignore the factor for hyperstatic. If I run this model and I look at the reactions in columns for these two combinations, they're going to be identical because we're only considering self-weight, dead, live, and the lateral action set as EQX. So we'll do that first just to kind of establish that that behavior in the model. We'll go ahead and execute the frame, and I'll execute for these two PDelta combinations. Okay, and I'm going to isolate the columns. We'll take a look at this lower column here on the bottom right of the frame, and we'll select the load combinations PDelta 1 and PDelta 2. We can see, for example, if we look at bending for the action combinations for columns, if I look at bending, I'll actually expand that again so we can see that more clearly where that comes from. The moment here is 242.5, and then if I switch it, it's identical. And if you run through all of these actions, you'll see that they're identical because they're not including those hyperstatic effects. So then this leads us to, well, how can we combine the hyperstatic actions when we design columns? We may want to include those reactions for the column design for this moment frame, for example, with PDelta. If this is not a PDelta problem, then you can directly solve a strength combination with hyperstatic and get a direct result. But what we're going to do is we're going to utilize a column design setting that allows us to combine the results from different analyses. And so the analysis we just ran was actually a global analysis. I ran it in multi-level mode. And if we go to the column design ribbon under design settings, we can see that there's a force source here that establishes what solution do the reactions come from that comprise these load combinations. And if I, for example, say my force source is the finite element model and solution that I just ran, and that source is actually, the FEM source is a global analysis. That means that for self-weight, for dead load, and for live load and EQX, whether it's PDelta or non-PDelta, we're going to combine the reactions from the global solution that I just ran to comprise this combination. For hyperstatic, I could actually rerun the model in single level mode, which is more in tune with reality. When we go to stress cables and introduce those hyperstatic reactions, we can rerun the model in single level and source those particular reactions only for the hyperstatic case, which is also included, let's say, here in PDelta 1, and the program will compile those reactions for the design. We're going to show that process now. So let's cancel out of here, and we're going to go back to load combos. We really don't need this one. What we do need, however, is a combination non-PDelta that includes hyperstatic, and this is more of a sacrificial combination where we just want to solve it so we can extract the solution for hyperstatic because it's not being solved in PDelta. So we'll say we'll use strength to do that. And so I'll go ahead and we're going to rerun through this entire process. The first thing I want to do is obtain a global solution. And if we go to the file structure for this particular model, we can see that the file structure includes solutions not only for global but also for single level. So under this folder, you can see there's a building solution folder which contains those files of data And there's also just a regular databases folder which contains the last run solution, whether it be global or single level. So the program can store that data so it can then compile the reactions for the solution for column design. And the first thing we'll do is we're just going to rerun this globally to go through the entire process. So we'll rerun finite element global. I'll go ahead and run those combinations. Go back to that. Okay, we have 3 combos. We're really wanting to design for this PDelta with the hyperstatic effect. And this becomes our global solution. Okay, so that's our global solution. And now what I'm going to do is actually just go to the level I want to design the columns for. So in single level mode, I want to design this column right here. If I wanted to design this column, I would actually go up to this level. Okay, so we're designing this lower level of columns, for example, and I'm going to now rerun this model in single level. You'll notice in single level the program filters out PDelta, so I can't even obtain a solution for PDelta in single level to begin with. I'm using my sacrificial combination that includes hyperstatic. If you wanted to, you could just simply set a combination 1 times hyperstatic. It could be set to no code check. It doesn't have to be set to strength. It just cannot be set to PDelta. So this is the solution I need to get this reaction. I'll say OK. That gives me the reaction for the hyperstatic load case. Now if I use the graphical reporting tools, we can predict what the, let's say the moment needs to be, moment SS, which is the controlling moment. We can predict what that needs to be and look like when we pass the data to S-concrete for the design. So I'll go back here to PDelta under PDelta 1, this combination here. I'll go to the combination results, moment about SS. And we actually need to go to, we need to go back to the global solution to see this. This is actually the moment for that combination with a single level run. So I need to actually come back to global. Let me just rerun global and note that reaction for the PDelta combo. Make sure that that PDelta combination is selected. Okay, so the moment for PDelta globally is going to be, moment about SS is 242.5. Okay, now I'm going to go back to single level. I just had to come back and do that to get that force. It wasn't stored graphically because my last solution was actually single level. So I didn't want to have to go dig through the file to find that, the text file. So now in single level, I'll rerun single level again. Okay, I'm just doing this for this strength, dead, and live, which includes self-weight, dead, live, etc. And the objective here is to say, okay, I've just run the sacrificial combination to be able to solve for hyperstatic. What is the hyperstatic moment? Well, here for PDelta, when I ran it globally, I was able to use the combination result to see what that moment is. I'm actually going to go back to loads and turn on hyperstatic. If we use the load case option, I can see individual load case results in columns. So hyperstatic, uncracked, that just means that we're using the default uncracked usage case for the finite element run for level mode. This is single level L. And if I come back to analysis and check the column actions for hyperstatic uncracked L, I can see the moment about SS hyperstatic wise is negative 48 kip feet. So if I take the previous result 242.5 and I minus 48, I get 194.5. Now these are graphical results, so these are truncated back to certain locations. For example, for a strip, you might get column face of support. These are top, bottom, and mid locations for the frame elements that comprise the beams. Those are the forces that we're looking at and the moments. So now I'm going to go to column design. And I'm going to say for PDelta, I want to use the FEM source global. That will actually give me the reactions for everything other than hyperstatic. And for hyperstatic, use a level solution and combine them. So we predict our moment should be around 190, 194 kip feet when we design this column. I've set the column up to a design group, 22 by 22, and now I'm going to I'm actually just going to go ahead and open this in S concrete. We could do this behind the scenes, but I'll just open S concrete to see what the forces are, the loads are that are being designed for this column. So if I select the column, right click, column design, open in S concrete will launch. And if I go up here to edit, loads, we can see the loads for this column. Here's the moment that is being used at the bottom. This is for strength and this is for PDelta. For PDelta, 192.4. They should be identical here because this includes the hyperstatic. This includes the hyperstatic from the other source. Okay, S concrete will launch now, and if we go back to edit under loads, we can see the loads being used. So for MZ, we predicted about 194.5 kip feet. The program's using 192.4 kip feet because of the sourcing of the global reactions for all other load cases other than hyperstatic. That's from the global solution, and the global solution itself, or the hyperstatic reaction, is coming from the local solution. So that's how we can combine the effects of hyperstatic and PDelta results for column design in Adapt Builder.